This video concerns the limit of quotients of polynomials where both the limit of the top and the limit of the bottom are 0. Such an example is the limit as x goes to 3 of x squared minus 9 over x minus 3. Now, in many situations, we calculate such limits by calculating the limit of the top and the limit of the bottom, and then taking the quotient of the two. But this only works as long as the bottom is not 0. And the problem in this case is not only the bottom 0, so is the top. So what we have to do is figure out how to deal with 0 over 0 forms, which are called indeterminate forms in limit situations. And we have no idea what the limit is without doing further work. With polynomials, that further work is always factoring. So in this case, x squared minus 9 factors as x minus 3 times x plus 3. And that means this limit can be rewritten as the limit as x goes to 3 of x minus 3 times x plus 3 over x minus 3. Now what we're going to do is we're going to regroup. And we're going to use the fact that the limit of a product is the product of the limits. And there's no problem here about zeros. So we write the lim as x goes to 3 of x minus 3 times x plus 3 over x minus 3 as the limit as x goes to 3 of x minus 3 over x minus 3 times the limit as x goes to 3 of x plus 3. The reason this works is that x minus 3 over x minus 3 is undefined when x equals 3, but it's equal to 1 all other times. And when you take a limit as x approaches a, x is not allowed to equal a, which means that x minus 3 over x minus 3 has a limit of 1 as x approaches 3. That means that we can rewrite this as 1 times the limit as x goes to 3 of x plus 3, and that limit is 3 plus 3 or 6. So the answer is 1 times 6 or 6. Let's look at a slightly more complicated situation. The limit as x goes to 4 of 2x squared minus 5x minus 12 over x squared minus 4x. Once again, when we evaluate the top at x equals 4, we get 0. And when we evaluate the bottom, when x goes to 4, we get 0. So again, this is a 0 over 0 indeterminate form, and we have to do some factoring. We can see that the denominator factors as x times x minus 4, but the numerator looks somewhat harder. Here, however, what we're going to do is use an important fact. And that fact is, if p of x is a polynomial and p of a is 0, then x minus a is a factor of p of x. In this particular case, that means that since 4 is a root of the numerator, we know that x minus 4 is a factor of that numerator. And we can write 2x squared minus 5x minus 12 as x minus 4 times a linear factor, which looks like ax plus b, and we want to find a and b. Now the nice thing here is, since x times ax has to give us 2x squared, we see that a is 2, and since minus 4 times b is the constant term and must be minus 12, we see that b is 3. Thus we can rewrite this limit as the limit as x goes to 4 of x minus 4 times 2x plus 3 over x times x minus 4. and then we're going to regroup and get the lim as x goes to 4 of x minus 4 over x minus 4 times the lim as x goes to 4 of 2x plus 3 over x. Now, the first limit is 1, and the second limit we can just get by plugging in, because it's a polynomial over a polynomial, and neither polynomial is 0. So we get 2 times 4 plus 3 over 4, or 11 quarters, and 1 times 11 quarters is 11 quarters.